I've got the bacteriorhodopsin protein. I've highlighted the alpha helices with red. I've used the scheme that gives the beta strands, beta sheets yellow, and the loops in green. And we've got all the other ligands and associated molecules using grey for carbons, red for oxygens in a more traditional format. Okay, so what can we do now? Well, it's time to start highlighting some of the interactions between these other molecules and the protein. Now, all of these around the outside, these are all lipids that are associated with the protein during the structure determination, during the crystallography. We can probably get rid of most of those. So simplest way to do that is make sure you've got residue selected down there, highlight all of those, and then right click and hide. There we go, gone. So now we can see that retinol sitting in there, but it's not clear how it's actually interacting with the rest of the protein. So to do that, what we need to do is find out what amino acids are important in that interaction. So the first thing we probably need to do then is go back to the protein data bank and take a look at this paper. Now, this paper describes the structure of the protein. It also nicely makes some comments in the abstract that you can use. So, for example, lysine 216, where the retinol binds. Okay, so that sounds like an important amino acid. So let's go and highlight lysine 216. So that would be the K there for lysine 216. Now, if your single letter codes aren't quite up to scratch, we can always go up here and change them to the residue names. And now we've got, it's much clearer that that's lysine 216. So click on that. There we go. And now it's highlighted. Zoom in a bit closer. And we want to show that as a licorice and with the spheres. There we go. But at the moment it's coloured using the colour scheme for the rest of the protein. So we'll want to change that, make it use the same colour scheme as the retinol. So once again, make sure it's selected. Right click and colour using by element, and find the colour scheme we used. I think it was that one. There we go. And now we can see this lysine side chain and how it's covalently bonded to the retinol. Right, very nice. So let's zoom back out of there. Right, now then, this cartoon representation, this is a bit of a cartoon-like representation though. We can see where the backbone goes, we can see the topology of the thing. Can't see much more information, like for example, the surface structure. But we can add that in. So if let's go to chains and click on the protein. There we go. Got the whole protein highlighted. What we can now do is right click and show surface. There we go. So now we've got the surface representation of the protein. And that's quite useful in a way. You can see sort of what the protein really looks like, if you like. But it's obscuring everything underneath, and it's coloured like the secondary structure, using the secondary structure scheme. So the first thing to do is to change this colour scheme. So we can use the advanced settings. If you haven't got those already open in a tab like I have, you can go to settings and edit all, and it will open that tab. Let's search for surface. I've already got that there, and we've got the surface colour that you can change. So let's change that to white. And now the surface is white. However, we still can't see anything underneath, but that's okay because we can change the transparency of the surface. So once again, select the protein, go up to settings, transparency, surface, and you select something along here. So let's see what 50% looks like. There we go, 50%, yeah, not bad. And so now we can see the surface of the protein, and you can see the retinol in the middle there. And if you wanted to use the middle scroll wheel, you can cut away at it to make it a bit clearer. Or maybe like that. Right. All right. So there we go. So that's some of the basic ways that you can manipulate the structure and the image of a protein, in this case bacteriorhodopsin. I'll show you maybe one more example and then move on to show you how you can compare structures as well between similar proteins, or even proteins with different, where you've had mutations and that's changed the structure of the protein.